Okay, so I made a model for the Earth's wind systems and that based on this top part here and the bottom part here in blue and then that white area there. Those are your, um, these are your polar zones. Then we have the temperate zones. I have the north and the southern temperate zones. And then I have the equator down the center here. And then I have the intertropical zone. That's this side up here and that side down here. So one of the things that we want to find out about is which way does the wind blow. So we have some very specific winds that follow along the Earth. So this is a very basic model, but I'm going to go ahead and use that. We'll continue with the Lego stuff on here because it just works out. So I'm going to start off and we're going to talk about the trade winds. Now the trade winds occur inside the intertropical zone. Okay? And to the north of the equator, they bend to the left. So they're going to go like this. So if I have the wind there, it's going to bend and go towards the left. Okay, I'll put them up here. That'll make it a little easier. And you'll see, so I'm going to go ahead and mark that. And this is where the winds typically go. And if you're seeing that it's going, these are actually easterly winds. So they take air systems out of the east and move them toward the west. Now we know this pretty well here in North Carolina because this is where the hurricanes come, and the winds that drive them are the trade winds. That's what helps drive them anyway. Okay, so I'm going to put those in, and you can see the prevailing winds go here, and they go from the northeast to the southwest. Okay, and that's typically the ones we have in the northern hemisphere. Now in the southern hemisphere, which of course this is all driven by air pressure, and we'll be talking about air pressure pretty soon, but we're going to be talking about winds this week because, hey, we have time for it since everybody's sitting around the house and not being able to do much there. So I'm going to go ahead and do that. So from this, in the southern hemisphere, there's the equator right here. Now it's going to blow opposite. It's going to go bend from to the right. Oh, excuse me, my fault. It's going to bend to the left, just like it did over there. What am I saying here? So let me go get my guys right in here. And as you can see, they're going to go basically the same way. So if you're going to push something on here, and they call these the trade winds, because people traded on there, and the things that they used mostly were sailing ships. And so the ships would get into here and they would follow the trade winds, and they would just tack along here, and they could basically go around the globe. Now this is all based on a flat Earth, and you can see I have a flat Earth here. But you can see there that it'll change here. So we've got that. Now that is our tropical zone. Now this doesn't mean every single wind every time blows the same direction. It does not mean anything. It's talking about prevailing winds, and so it's more often than not moving that. Sometimes those winds will change, and sometimes they'll stop. And they have these areas that are in here they call the doldrums. So if you're in a sailing ship and you're riding along, and all of a sudden you get into a doldrum, you could be weeks without moving more than a few feet. And if you've got a big, lunky wooden ship filled with stuff in it, and you don't have enough oars and enough strong people to paddle it along, well, that's not going to do much good. So here we go. The ships would come along here, and they will use these winds to either tack against them or for them, and they try to keep in there where they have a steady wind. And the sailors without time, they knew where these winds were, and they were very good at finding that out. Okay, so next part on here, we're going to look at the winds that we have here. We're in this area, I call it the temperate zone. But again, this is the area between, and these aren't perfectly set up as, I have the Lego, I have to go by their little dots. This is the area between the intertropical zone and in the Arctic. And this is where we live in. We're in this area here. And there's also another area corresponding in the southern hemisphere, goes along here. Okay. Now, the interesting thing about this is that, well, this is prevailing low pressure here. That's why we get things like hurricanes going there, big storms and all that. Low pressure just means stormy. Just means stormy. We're going to explore that next week. And then we get in this area, and well, all of the deserts are here. I mean, if I look at this, maybe this is the Southwest United States over here, and then you go across, and this is the Sahara in Morocco. Come down in here, and this is the outback in Australia. Those are all deserts, and we're going to go ahead and look at those. Now, these were all winds that were easterlies that we had here, right? So let's go ahead and take a look at the system here, and I'm going to start in the southern hemisphere, and now we're going to look at them, and they're going to be going, they're going to be going from the west to the east. So these are prevailing westerlies. And in North America, of course, we know this because we see our winds. Basically, they come over, bring the storms. They hit California and Nevada and Oregon and Washington and all that, and then they move eastward and eventually go across the Great Plains, and then they go so on and so forth. They go towards the East Coast, then off the East Coast and into the Atlantic. Okay, so let's go ahead and put a couple more markers here. And this gets there. This gets our southern part here. Again, the winds are going opposite. These ones are going to the east. So these are easterlies. Okay? And this area is an area of low pressure. Typically, of high pressure. And the high pressure means not very stormy. I mean, they do get storms, of course, but it is not prevailingly a really stormy place. So therefore, that's where they go. Now let's go ahead and put our stuff in for the northern hemisphere, because this is where we live here. And I'm going to put that in, and here's our easterlies there. Boom. 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 And if you have the Legos to do this at home, you could probably do that and use anything as a pointer. I just found these in there, and I said, yeah. Now I remember why I grabbed so many of those when I was at the Lego stores, because I could use them. And you can see they kind of go matching going this way, then matching going this way, then matching going this way, then matching going that way. And now we're going to look at the polar zones, because we know that this is going to have low pressure because it's got a lot of the heat. The sun is centered either... It's never really farther north than this line right here, which would be the Tropic of Cancer. And down here, the Tropic of Capricorn, down here. And so once the sun is directly over, well, the sun is where we get all our heat, okay? So that's where you have all that in there. Even though our big deserts are there and there, the heat's right here, the most of the heat, the average heat, So anyway, here we go, and the air typically rises here. Therefore, we know that because it is a lower pressure. You have that heat in the air, so it's going to rise as it becomes less dense. Well, anyway, so then you have the other air coming in. You get a lot of convection and everything else along here. Remember convection? We talked about that. Okay, so now we're going to look here at these guys here, and not as stormy, although, hey, if you're over here in California, you're going to see a lot of snow in the Sierra. You're going to see a lot of snow in the up in the Cascades in Oregon and Washington. Of course, we're going to see over here, you're going to see storminess down in like South America down here and a little bit, but mostly not. Okay. Now let's move into the Arctic zones. We have the two Arctic zones here, and these are a little over-representative on the size. I really probably should have done this this should have been at 60 degrees, 90 degrees north, 60 degrees north, 30 degrees north, 0 degrees, 30 degrees south, 60 degrees south, and 90 degrees south. So if we're looking at the Earth as a flat thing, and we can only study the map, that's what we're looking at here. So let's go ahead and put some of those in here. And of course, these ones all went this way. Guess which ones these ones go? These up here are, again, this is this is really cold air. If it's really cold air, it's going to sink, right? So this is going to put on there very high pressure. So if it's high pressure, well, it's going to be kind of like this here. Let's go ahead and put that in there. And this, for this one here, it's going to be going here. And I'm just going to put some in right there. And they're going to be prevailing easterlies. Okay, I'll pop a few of them in here. Keep the model going. Hopefully I didn't mess it up too bad. Okay, there we go. All right, so we've got some of those measuring that. Well, down here, these are also going to be, again, very much high pressure, sinking air. So let's go ahead and put those in. These are also going to be easterlies. And so they're going to go right here. Oh. And put some of those in. Some more. And some more. Now, according to these things on here, where you do have all this high pressure, and we had some high pressure up here, we're looking at those places having very much colder air, because they're that's where we get the high pressure with that colder air. And there you go. So there's our wind patterns here. These would be the polar easterlies there. These are polar easterlies down here. These are the mid-latitude, or the, if you can call that, or you can call it the temperate zone. They're going to be easterlies, or excuse me, westerlies. We've got the westerlies there. We have the westerlies down here. And then when we have in the center, we've got right there with the equator and the intertropical zone, we're going to have them all, they're going to be going from the east to the west. So they are easterlies. Now some of these obviously go one direction. They bend one way, and these bend the other. Okay, so that's kind of how the wind patterns work on the Earth. But of course, this doesn't take into account oceans, land masses, high mountains, and everything else on there. So, but this does kind of give you an idea of the way the Earth can be, divvied up like that. And there you go.